Hello and good morning, everyone. This is Ray Cheney from DEP. This is our second seminar here, and my role here is I'm Director of Pre-Sales and Product Development. I have my colleague along with me. I'll allow him to introduce himself.
Good morning, everyone. My name is Pratik, and I'm the technical support for DEP's product MeshWorks. I would be also doing this webinar along with Ray today.
Okay, with that being said, today we want to show you guys a couple of things that the MeshWorks has called the design enablers. The design enablers are something that you can basically link along with your normal optimization tools in order for you to further be able to optimize your product and be able to fine tune it as you go forward with any kind of optimization study in terms of mass, frequency, and things like that. With respect to any kind of frequency analysis and things that you guys may be doing at your facility. So with that being said, I'm going to get started with the first demo. The first demo we have here is we're going to have something called the doubler creation. This is a local floor model here, and you can see we have a couple of cross members. Now, we ran some analysis and we saw that we need to strengthen this locally in this area here. MeshWorks has a nice cool feature called the doubler creation to where we can create a doubler and we can also parameterize this doubler. We can create one doubler, or we have the option to create multiple doublers, or we have the option to parameterize in such a way to where we can control the doubler length itself. So I'm going to go into the doubler parameter. And the first thing I'm going to do is specify my geometry. This is the portion where I want to create my doubler. And the next thing that I'm going to do is create a plane. Now, I want my plane to be in the y-axis. Now I want to select the actual point to where I want the plane to pass through. I'm going to select this point, say execute, and say return. Now if you see this doubler direction, I have the option to either grow the doubler on one side or another of the plane, or I have the option to distribute the doubler equally on the middle of the plane. So I'm going to use the plus or minus option. And now I want to preview the doubler. So now you can see that it's taken the base component and it's created a doubler in the middle of the two components, being the floor and the cross member. So now I want to accept that and say return. Now I want to simply just specify the properties associated with this new doubler. So I'm going to say accept. Now my property has been specified. I want to adjust the penetration because as you can see here, when this doubler is created, the floor or some of the surrounding components has to be able to adjust to the new thickness that's going to be added in that location. So I'm going to click on adjust penetration and select the follower components. For this example, we want the floor to be adjusted. Sequence is going to have one component. The sequence is just going to be just one. In this particular situation, if we had multiple components that's going to sandwich the new part created, then we can specify in what sequence we want to adjust to where we have a method called the follower method, to where we can select the sequence and how the cross members or the actual floor is going to be following, and this will automatically readjust your penetration when you create your new doubler. So I'm going to say accept. Now I'm going to specify the connection. For my connection type here, we want to use the ACM shell gap. Constant diameter we want to keep at 5. We want to allow it to be based on connecting parts. Now, we have other options to where we can move spots to new parts. We can move spots to existing parts. Or we can keep the option that we have selected, which is based on connecting parts. I want to preview the welds. And as you can see, that we can preview exactly the location of where the new welds are going to be. So not only can you create the doubler, but you can automatically tell the software to connect the doubler to the surrounding parts. So I'm going to accept this, say return, and I'm going to click on create and parameterize. Now as you can see here, we have two options. The first thing we can do, I want to show you guys that we can execute this as a simple one-time execution, or we can execute it as a parameter. While executing as a parameter, you can see that we can control the doubler length. I can change the max value here, then I can tell it exactly what value that I want the doubler to be created. Second option, we can have the doubler, we can have a number of doublers as our parameter. Here we have a max value of 3, and we can select a current value of 1, 2, or we can give it the max value. Within that, we can parameterize it in two different ways. We can have a pitch value, parameterize it by pitch, or we can parameterize it by doubler range. For this example, we're going to use the pitch option. We're going to give it a pitch of 50 millimeters. So when we say preview connection, we should see how MeshWorks is going to take this crossmember as a base component, create two doublers, and automatically create a connection between the floor and the initial crossmember. So we can give it maybe another 50 seconds or so, and we can see the doubler being created. So as you can see here, doubler is being created with a pitch of 50 millimeters and a current value of 2. So once the geometry is basically generated, then obviously all the penetrations and everything will be automatically taken care of. The next demo I would like to show you is called the part extension demonstration. There are going to be multiple cases to where you guys are going to need to be able to extend geometry and create geometry in different locations. As you can see here, the one input that you guys have to have is just the trajectory lines. So we have the option in MeshWorks to take a cross-section of a component, create a trajectory line, and extend that using our part extension parameter. So in the parameterization tab, we can go to part extension. We can go to create. We want to select the part that we want to extend. It's going to be this part here for this example. Now it's going to ask me to select the cross section. Now you can see here the MeshWorks automatically turns everything off and allow you to be able to simply select the appropriate cross section. Once the cross section has been selected, you can simply extend in two ways. You can keep it on default for cross section. You can use the guiding part, or you can use select trajectory lines. For this example, obviously we have the trajectory lines here to select. I'm going to select all my trajectory lines. Now for the length of extension, obviously I can control that. For this example, let's use a length of 200 millimeters. Now I can preview this, and you can see how MeshWorks nicely goes ahead and extends the part based off those trajectory lines. In the same way as you saw the doubler creation, if you guys were to have a mating component here, or multiple mating components, MeshWorks has the intelligence to obviously extend this part and obviously connect the components using any kind of weld method that you guys choose for your particular analysis based off of your company's guidelines. The first example, you guys saw how I could do the shell gap. And we can also do a number of different other connections as well. So now the third demo is going to be called the part contraction. Now, if one can extend the part, one should have the capability to retract the part. So I'm going to go on the parameterization tab again. And I'm going to go on the part extension and select create. Now you see here, we have the capability to extend the part, or we can click on part contraction. So I'm going to select on the part to be contracted. Now I'm going to select the end selection. So now this is the section in which I want to basically contract in this example. So now it nicely previews a 1D representation of the area to where it's going to be retracted. Now I need to simply create a reference plane. And we want to leave it in the X direction. And we want to simply select a node on the 1D element and say execute. I'm going to say return. And for my contraction length, I'm going to put in the value of 40. And I'm going to say preview. Now what's going to happen here, MeshWorks has the intelligence to not only contract the part, but it will automatically go ahead and unrealize the welds that are no longer going to be valid. As you give the software a couple of minutes to go ahead and create this, you'll see how within a few clicks, we can automatically retract the part, and as you can see here, it automatically unrealized those welds that were existing. So now I'm going to hand it over to my colleague, Pratik, and he's going to show you some more remaining demos.
Hi, so I would like to start the demo with the seam weld parameters. Initially, I would like to talk how the weld lines for the seam weld can be created, and then we can see how these seam weld can be parameterized. Now, in order to do that, I'm going to choose these two paths. I'm going to choose these two parts where I would be creating the seam welds. And as you can see, I don't have any seam weld lines over here. So the best way, using MeshWorks, it's very easy to create a seam weld line. For that, you can either use the CAD curves, you can either use these two paths as reference, or even you can use 1D elements to create the weld lines. So I will be using 1D element over here to create the weld line. To do that, I'll go to Tools and do edge tracking on one of these components by using Nodes by Path option. And now you can see how it has created the edge. Now using this edge, I'm going to convert this edge to a weld line. To do that, I'll go back to Model Assembly module, and I have a seam weld over here. I say create weld lines, and you can choose the weld element type for the seam weld that you will be using. You can use rigid, you can either use beam, quad, or hexa along with RDE3 as well. I would be using a quad element over here. And create by option also, as I was saying, you can either create the weld lines by parts from 1D, from 2D elements, or from any existing welds, or from even nodes, as well as CAD curves. So I will be using here from 1D element. Then I'm going to select 1D element, which we just created. And then I'm going to select my master and the slave parts. Now, the master and the slave, these are the two parts where the seam weld will be created. So you can select any of this part as master and slave. It's just for nomenclature purpose. So I'm going to select this as my master. I'm going to select this as my slave. And simply say create weld line, and we see how weld line is created. Now, once the weld line is created, we can also see how welds can be created here. So I go to create welds. I will change the selection of weld type to quad and select the weld line. And you can see when I change my selection to quad, weld type as quad, automatically the weld line that were assigned as quad before, while they were created, those weld lines will automatically get highlighted. So I'm going to select the weld line. And if you want to move the seam weld to a new component, you can move it to a new component, or if you want to move it to an existing component, you can do as well as that. If you want it to be heat affected zone, all I have to do is simply check on this option. And then you can also select what kind of a seam weld realize you require, whether it is going to be continuous, whether it is going to be continuous with gap or discrete. So if I choose continuous, I can give a weld clearance, as well as if I want to have a weld contraction at both the ends, if you want, or even I can say just, you can select any one end point wherein you want to have contraction. So I'm going to select both the ends for demo purpose and say 40% about both the ends. And then you can select the property, and I can say realize. Now you can see how it very nicely it created a seam weld, a quad seam weld, and also we can see that how it has contracted about 40% at both the ends. Similarly, even if I choose continuous with gap, I can also give the number of stitch welds I want between the length of this weld line as well as the stitch weld length. So if I say stitch weld length of about 20, and if I want about 5 stitch welds, I simply have to change the number of stitch welds and say realize. And we can see how nicely it's going to create 5 different stitch welds over the entire length of this particular weld line. And I can also go ahead and create a discrete, and I can give how many, just the number of welds that I would require, and simply say realize. And you can see how it discretely created about 5 seam welds, and the pitch between the welds is calculated, is automatically calculated over the entire length of the weld, as well as you see it is still maintaining a 40% contraction at both the ends. Similarly, once the weld lines are created, whatever we discussed right now is a one-time execution. So if I want to parameterize it, once the weld line, the seam weld line is created, I go back to parameterization. I have something called as seam weld parameter over here. So I can go there, create, first choose the weld type. It's going to be quad. Then I'm going to select the weld line. And then I can select here continuous or continuous with gap. Again, same thing. You can give the percentage of weld contraction length, select the property, and simply say preview. Now it's going to preview. Usually for parameterization, it usually takes a little bit longer time. And as you can see, it already has created over here. Similarly, you can also, while parameterizing, you can parameterize the length of the stitch, the stitch welds, or the number of stitch welds, as well as the pitch, as you can see here on the PPT. So the next demo that we will be doing on is about gauge and material parameter. So here, using MeshWorks, gauge as well as material also can be created as a parameter. I can take any part and I can give different thicknesses to run the optimization, and then we can generate many different designs with different thicknesses. Now to start with gauge parameter, I'm just going to use these two components for my gauge to change the gauges. So I go back to parameterization, I go to gauge parameter here, say create, and you can either create it by property or you can create it by part. So currently I'll do it by part, and I'm going to select the part for my gauge parameter. So I'm going to select these two parts, accept, and click on create. Once I click on create, this table is going to pop up, which is going to show which part we have selected, what are the material that has been assigned, and what is the base thickness that has been assigned. And here I can assign a minimum thickness as well as a maximum thickness. So if I assign 0.6 as my minimum, I can assign 1.2 as my maximum for both of these parts. And I can say create. Apart from this, I can also group if I have symmetrical parts, I can group them. And if I group them, I have the option to assign the thicknesses based on absolute values or as well as percentage values also. So I'm simply going to say create, and that's all. So the gauge parameter has been created. Now once the gauge parameter is created, while defining the design, you can choose an appropriate thicknesses for a particular design and generate that design with that assigned thickness. Similarly is the material parameter. So I go to the material parameter and say create, and you simply have to select a part for which you want to create material as a parameter. You can choose one part, you can assign multiple number of material for that one particular part, and then go ahead and generate with each material as well. So I'm going to select this part, accept, and say create. Now once I create, again, just like gauge, this parameter, this table pops up. I'm going to simply expand this table, and you can see it shows which part we have chosen, what is the thickness given to it, what is the baseline material that has been assigned to it, and you can see here design variable name. So when I click on here, I can go ahead and I can select material from existing table, and I can assign as many material as I can, as I would require. Simply say accept and say accept, and this parameter, and click on create and return. So now basically all those materials that we chose, those have been assigned to this particular component. So whenever I would define my design, I can choose any material for that particular analysis or for that particular design, go ahead and generate a new model with that material being assigned to this particular component.
Excellent. Thank you, Pratik. So this will conclude our demos, and we want to say thank you all for attending from my side here at DEP.
Thank you very much, everybody.
Thanks once again. We're going to conclude this webinar.
Thank you.